Welcome. In this video, we'll be solving trigonometric equations involving cosecant, part 1. Let's take a look at our first example. Solve the equation given below for theta is greater than or equal to 0 and less than 2 pi. Here we have the equation to be negative 3 cosecant of theta is equal to 6. The first thing we want to do is to isolate cosecant. So let's go ahead and divide both sides by negative 3. By doing so, we get that cosecant of theta is equal to negative 2, because 6 divided by negative 3 becomes negative 2. Now, recall that cosecant is the same as 1 over sine of theta. So we're going to write this equivalent equation. 1 over sine of theta is equal to negative 2. And then, by taking the reciprocal of both sides of the equations, we get the reciprocal of 1 over sine is simply sine of theta, and the reciprocal of negative 2 is simply negative 1/2. Now, this is an equation that we already know how to solve. Since we're dealing with sine, we're dealing with the y-coordinate. So we want the angle that will have a y-coordinate equal to negative 1/2. So we take a look at your y values here. Okay, so we are going to go here and see, okay, where do we have a y-coordinate of negative 1/2? And it happens to be here. And if we were to reflect this one across the y-axis, it also happens to be here. So the angles for theta that will make this a true statement happen to be 7 pi over 6 and also 11 pi over 6. Therefore, the solutions to the described equation are 7 pi over 6 and 11 pi over 6. Let's see another example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. So once again, our goal here is to isolate the cosecant. So let's add 1 to both sides, thus giving us the following equivalent equation. Cosecant of theta is equal to negative 3 plus 2 times the square root of 3 all over 3 plus 1. Now, we're going to multiply this one by 3 over 3 so we can get the same denominator. So we have cosecant of theta is equal to negative 3 plus 2 times the square root of 3 plus 3 all over 3. And now notice that we can cancel the negative 3 with this positive 3. So we get that cosecant of theta is equal to 2 times the square root of 3 all over 3. Now what we want to do here is to get the reciprocal. So let's actually take the reciprocal of those, but before we do that, we can actually rewrite this one so you can see the extra step here. This is 1 over sine of theta is equal to 2 times the square root of 3 over 3. And now we can definitely take the reciprocal of both sides of the equation. So the reciprocal 1 over sine of theta is sine of theta, and the reciprocal of 2 square root of 3 over 3 is 3 over 2 times the square root of 3. However, notice that the denominator is an irrational number, so let's rationalize that by multiplying by root 3 over root 3. So now this becomes 3 times the square root of 3 all over 2 times the square root of 3 times 3, which is 9. The square root of 9 is 3, and 3 here will cancel, so you get that sine is the same as the square root of 3 over 2. Now, we're looking for the angles that will have a y-coordinate of square root of 3 over 2. So let's take a look at our unit circle. And we see that we're looking for y-coordinates of root 3 over 2. Well, here's one of those points. If we were to reflect that across the y-axis, we get the other one. So the angles that correspond to them are pi over 3 and 2 pi over 3. Therefore, theta could be equal to pi over 3 or 2 pi over 3. And that is the solution to our original equation. So notice that here what we were doing was to actually rewrite the original equation in terms of the isolated function. Once we did that, we wrote the equivalent equation based on the reciprocal function, and then we took the reciprocal of both sides and solved the given equation by using the unit circle. So that concludes this particular video on how to solve trigonometric equations with cosecant part 1. Thank you for watching and have a wonderful day.